What?
If it says AD, that means
Anthony,
not.
Dominic.
Yeah, if it says AD, that means.
All right. Can everybody have a seat? Stop. Listen, guys, your distraction today is going to mean that we don't get through as much of the lesson as I want to. Okay? Now, listen, I think that it's been a long time since we've done graphing inequalities, and it's okay. Remember, what we're looking at here is the final exam in the Regents, and we want to make sure we can do a question like this. Obviously, it was taken right off the Regents. Now, I don't really care if you got a 0. The whole purpose of the first quiz is to show you what you don't know. Now, if you got a 0, and you go home this weekend, and you do not work on this quiz, that's a problem, and that I care a lot about. But if you got a 0 today, and you go home and you work on it, and then you get a 75 or 100 when we get back, that's good. The way I graded it was very simple. If it was perfect, you got 100. If it was half right, more or less, you got a 50. If it was less than half right, you got a 25, or 0 if it was really bad. And then if it was mostly right but not perfect, you got a 75. So let's go through this and try to work this out together. First one, Edith babysits for 4 hours a week, or for X hours a week, at a job that pays $4 an hour. And then she works at the library for $8 an hour, and that's Y hours each week. So it goes a little further, and it says that she wants to earn at least 80 bucks. That means 80 or more. So if I take the number of hours at the library, X, multiply by 4, and then the number of hours at the library and multiply by 8, because the library is $8 an hour, and the babysitting is $4 an hour. And if I add them up all together, I have to get greater than or equal to 80. Then the next one says that she doesn't want to work more than 15 hours. So that, therefore, X plus Y, hours at the babysitting, hours at the library, have to be less than or equal to 15. So then I need to graph both. For the first one, I subtract X from both sides, and I get a slope of -1, a Y-intercept of 15, and you can see the blue graph right here. Y-intercept is 15, slope of -1, and I just draw that line, and because it's an inequality, and it's less than, I shade below. Where do you shade for greater than, everybody?
Above.
Above, good. All right, so now let's work on the more complicated one. I got to subtract the 4x from both sides. I've got to divide by the 8, and I get y is greater than or equal to -1/2 x plus 10. So in this case, the slope is -1/2, and the y-intercept is 10. So I go over to 10, and I go down 1/2, down 1/2, down 1/2, all the way through, and I draw the green line, but this one is greater than or equal to, so I shade above. And then it wants one set of values, coordinates, points, whatever, so that I satisfy the conditions of not working more than 15 hours, but at the same time making at least $80. And that's going to be the double shaded area. So I made a red dot in there. You pick any point in that double shaded area. Try to avoid the one here, because if one of these lines was broken, then it wouldn't work. So you want to go where it's heavily shaded. It's best that way. I chose 5/9, 5 hours babysitting, 9 hours at the library. Okay? So that's how we do it. So in retrospect, I don't think it was a matter of it being too difficult for you to do. I think it was a matter of it being a long time. And now that you're reminded, and if you practice this weekend, I think your grades will skyrocket come Monday. Does that make sense to everybody?
Yeah.
You with me on that? Okay, very good. Listen, this was, I believe, a 4-point question on the Regents exam, and in order to get the high grades, and I certainly hope there's a lot of people here who are looking at really nailing a high grade on that Regents. By high grade, I define a high grade personally as a 90 or better, but even 85 to 90. 85 and better is a high grade. 90 is a really high grade. And it is challenging to get on this test, and you can't afford to miss a question like this, because this is a 4-point question, and if you get a similar grade on it to what you just got on your quiz, it really hurts your chances of getting a 90. Almost hurts your chances of an 85. So we have to be prepared, and performance is a function of preparation. So this is all about preparing. That's what we're doing. Okay? Any questions? All right. So now, speaking of old Regents exam questions, when 5x plus 4y is subtracted, and so on and so forth. So let's go through each of these questions. And 3. So, projection made. When 5x plus 4y is subtracted from, and we've talked many times this year about the importance of the word from.
If it's from, it kind of means like you switch the order. Like instead of
That's
doing
right.
5x minus 4y, you would do 5x minus 4y minus
That's right.
5x plus 4y.
Be careful about the phrasing, switch the order. The way I like to describe it, and I think this is what you meant to say, is from goes first.
Yeah. Now when you're doing this equation, apparently there's gonna be a bit of a problem because like there's a negative, and you can't subtract negative 5 from 5, but you need to do it like a similar way of subtracting positive 4 from negative. What do you?
I know what he's trying to say. One simple thing to do, Anthony, remember, Anthony's trying to break it apart piece by piece.
Yeah, what I'm trying to do is like I also wanted to make sure it's like plus, so that way I can
Right.
change both of them to negative. Like so instead of doing minus 5x plus 4y, it would be plus negative 5x minus 4y.
Right, and I think a really good way for every single kid to make sure they do that, every time we write this, I think I've mentioned this a couple of times, put the -1 in front and distribute it. Then you'll get 5x minus 4y minus 5x minus 4y. And now you do your business as usual.
Now when you do the operation, you can do it like 1 by 1. So if you subtract 5x from 5x, you would get 0x. So
That's right.
it's gonna
Good.
We know that. And if you subtract 4y from negative 4y, you would get negative 8y.
I prefer
And
to say,
therefore-
yeah, hold it, listen, slow down. Your answer's right, negative 8y. But I prefer to say if I combine my negative 4y's and my negative 4y's. Right.
So if you combine negative 4y and negative 4y with each other, you get negative 8y, which is 4.
That's right. Perfect. How many people got choice 4? All right, I'm looking at roughly half the hands in the room. We want to nail that 100%. So don't forget, from goes first, and don't forget to distribute the -1, okay? Next up, the accompanying diagram shows a box and whisker plot of student test scores on last year's math A midterm exam. What's the median score? The median's right here, isn't it? Everybody, right? What's this one called?
Minimum.
Minimum. This one?
Quartile 1.
First quartile. Median? Third quartile. The median is quartile 2. Quartile 3, and then maximum. So this looks to me like 81. 81 is the correct answer. Roughly, what's the interquartile range? What is the interquartile range? We spoke of that one of the days we were in the library. Anna?
Quartile 3 minus quartile 1.
Yeah, which looks like it's about 87 minus 70. I'm not standing directly in front, so it should be around 17. All right, any questions? All right. Next up. Oh, this isn't good. Huh. I guess I'm gonna have to reach over here to scroll this up. All right. Now, the equation P equals 2L plus 2W is equivalent to. So what I want to do here is, this is a literal equation where we solve for, they're solving for L here, so I'm going to do L. P equals 2L plus 2W. So my first step is to subtract 2W from both sides. Die. P minus 2W equals 2L, then divide by 2.
Therefore, the answer would be 1.
Yes, it would. Choice 1 is correct. Okay, now as far as the next question goes, you don't need to do this one. I'll do it anyway, because it's not very difficult. On our regencies, you do need to know how to simplify radical 75. You do not need to know how to add radicals, but it's really not difficult. Let's simplify radical 75. What's the biggest perfect square that goes into 75?
25.
25, good. So I get square root of 25, square root of 3. So what's the square root of 25?
5.
So I get 5 radical 3, and it says sum, that means to add. So look, if I had 5x's plus 1x, what would I have?
6.
6x. If I had 5 puppy dogs and 1 puppy dog, what would I have?
One
6
like
puppy dogs.
puppies.
That's right. So if I have 5 radical 3's plus another radical 3, what do I have?
6 radical 3.
6 radical 3. Choice 3 is correct. Okay? So it's not really hard if you have to do it anyway.
I'm confused.
Do you understand how to get 5 radical 3?
No.
All right, you should. And I don't mean that to make you feel bad. What I'm suggesting to you is, because performance is a function of preparation, there's this little thing called extra help on Monday mornings, Wednesday mornings, and Thursday mornings, and Tuesday afternoons. Come in and get down pat how to do this. The biggest perfect square that divides it to 75 is 25. So I'm gonna rewrite this as 75 is 25 times 3. And the square root of 25 is 5. So I get 5 radical 3. That's what the left side equals. Then it says sum, so I have to add, there's my add, another radical 3. So if I had 5 shirts and another shirt, I'd have 6 shirts. If I had 5 notebooks and another notebook, I'd have 6 notebooks. If I had 5 X's and another X, I'd have 6 X's. Now remember, an X stands for anything. So what we're really getting at here is some kind of an eternal truth that says 5 of anything plus another one of that same thing is always 6 of that thing. But that's what we have here. The thing is radical 3. I have 5 radical 3's plus 1 more radical 3. What is that all together? 6 radical 3's. Now, to be clear, adding radicals is not in the Common Core curriculum. However, breaking them down is. So you need to be able to do this piece right here. If you can do that, you're good for the course. Okay? All right, so now let's go to today's lesson. Which, to tell you the truth, it's a Friday and I had breakfast with Mr. Duran and Mrs. Bing, so I don't even remember what it's about. All right, National Climate Data Center collects data on weather conditions at various locations. They classify each as clear, partly cloudy, or cloudy, using data taken over a number of years. X is elevation above sea, Y is the mean number of days per year, W is the mean number of partly cloudy days, and Z is the mean number of cloudy days per year. The table below shows the data for 14 U.S. cities. Now, there's something, usually I have this stored as a PDF, and it's pretty easy to work through. I don't know what the deal is now, but good. All right. Now, so we look at the table, and basically we have 4 columns. 1 column for each. And then we also have a column for which city we're talking about.
Hey,
Okay.
that job.
Yeah. All right. So we're looking pretty good there. Anybody have any issues or any problems? Okay. Now, there's a scatter plot of the data of the elevation and the mean number of clear days. So there's my scatter plot. Now, you did do scatter plots last year. All a scatter plot is the combining of a particular number of days with a particular elevation. So for instance, this guy here is an elevation of a little more than 5,000 and a little more than 175, clear days, okay? So apparently, the higher elevations, can you see that if I was to draw a line of best fit, I hope you remember what that is. Line of best fit pretty much goes through the middle of it. If I was to draw that line of best fit, can we all see there's a positive slope here? And in terms of lines of best fit, we call slope correlation. What does the word correlation in the English language mean?
It's showing like a pattern.
Yeah, some kind of a connection. Not necessarily cause and effect, but a combination. Like for instance, it's generally the case that the more hours you spend studying, your grades generally what? Improve. They generally go up. Now, that is not true for 100% of the kids. Some kids get really, really high grades and never ever do work because they just got it, okay? But for the most part, it tends to be that the more hours you work, the higher your grades go. That's a positive correlation. A negative correlation would go like this. The more hours you work, the less sloppy mistakes you tend to make, or the less misunderstandings you tend to have. So a negative slope is a negative correlation. A positive slope is a positive correlation. This is positive. Now, what kind of questions did they ask? Because I don't really want to scroll past this.
Do you see a pattern in the scatter plot, or does it just look like a data
Okay.
points?
So do you see a pattern? I do see a little bit of a pattern. What's the general pattern that you see?
The higher elevations.
The higher elevations have what?
Clear days.
More clear days. Okay, generally speaking. Think of it as they get up above the clouds, or they don't have the ocean there to send fog in. Okay? All right, what's the next one that they ask or say?
How would you describe the relationship between elevation and mean number of clear days for these 14 cities?
I would say the higher the elevation, the more clarity. And what do they ask next?
That is, does the mean number of clear days tend to increase as elevation increases, or does the mean number of clear days tend to decrease as elevation
Everybody?
increases?
Increase, good, okay. So there is our first scatter plot. Now let's go to our next scatter plot or plots, as they will appear.
Yeah, there was a third question.
I thought that was the third question.
No, it was like 2 questions in one.
Oh, okay, what's the last one there?
Do you think that a straight line would be a good way to describe the relationship between the mean number of clear days and elevation? Why do you think this?
Oh, well, what we don't want is this. Just one general trend that goes through them.
Play connected up.
Yeah, no connected dots. All right. So, what? I really have to get my glasses on to read this. All right. So, below are 3 scatter plots. Each one represents data set with 8 observations. The scales on the X and Y have been left off these plots on purpose, so you'll have to think carefully about the relationships. Okay, number 4. One of these scatter plots represents the relationship between height and weight for adults. Which one do you think would represent the relationship between height and weight? Evan?
First one.
The first one, very good. As you get taller, you tend to get what? Heavier. It's not completely true. There are very tall kids who are very skinny, who are light, and short kids who are chunky, who are heavy. But generally, it's true. That's why the data doesn't go exactly in a straight line, but it more or less approximates. If one of these scatter plots represents the relationship between height and SAT math score, which one do you think that is? Spencer?
The third one.
The third one. There is no relationship. Your height has nothing to do with your intelligence. Sorry, you super tall people in here. And for you not so super tall people in here, you're welcome.
Thank you.
Next, yeah, you go ahead. If one of these scatter plots represents the relationship between the weight of a car and fuel efficiency, which one do you think that is? What do you think happens to how fuel efficient a car is as it weighs more and more? What happens to the gas mileage?
Goes down.
Goes down. So which graph looks like as the weight goes up, the mileage goes down? The second one. Good. Okay. Which of these 3 scatter plots does not appear to have a linear relationship? 3. Very good. Okay. And that's because there is no line of best fit that you can really put through there. All right. When a straight line provides a reasonable summary of the relationship between the 2 numerical values, we say that these 2 variables are linearly related and that there's a linear relationship. So let's go to scatter plot 1. And this guy is all about the number of cell phone calls and the age. I think it's fairly accurate to say, well, you know what? Nowadays, the whiteheads, because I see them when they're driving. Do you know what I had the other day? I was furious. I gotta get places. I gotta go. I got things to do. I didn't get done working last night till 10:20 at night. I gotta get things done. Boom, 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 boom. Move along. I get behind this car on Waverly Avenue. Oh, it's a whitehead. Immediately, whiteheads are.
An old person
The
who's
old
head,
people.
they're so old. Their hair
And they drive so slow. And then you think you see them put their blinker on like a quarter mile before they're gonna turn. And your hopes build up and you're like, yes, yes, yes. And then they got this like walkie-talkie network thing going on. Because just as he's about to turn, another whitehead cuts in front of you. But I got really mad driving behind, because you know Waverly kind of opens up there where you can pass, and it gets 2 lanes. So I'm behind this whitehead, and finally I get the clear, and I'm zipping by, and I see the whitehead texting as they're driving. I'm going, oh, like the 2 kisses of death. The young people text. You ever get behind the driver and all of a sudden you know they take out their cell phone? Because they're like driving along a little faster than the speed limit like most people do. And they're driving along, all of a sudden they're like, and they start rearing to the right, rearing to the left. You know they're texting. Either that or they're drinking, one or the other. Okay, so I think it's realistic that there's very few 60-year-olds and the young people have lots of time put in. Is there a relationship, everybody?
Yeah.
Yeah, we would say, is this a positive or a negative relationship?
Negative.
Negative. It says negative correlation. As the age increases, the time on the cell phone decreases. All right. Let me see what the next question here says. Oh, never mind. Scatter plot 2. What do we got here? What's that left-hand side say? Oh, moisture content and frying time. Is there a relationship between the moisture content and the frying time? Anthony,
Yes.
positive or negative?
Negative.
Very good.
Because
Excellent. Now,
as a
one
parent-
thing, hold on, one thing you should know about correlations is they can be strong or they can be weak. Now, a very strong correlation looks like this. The points almost form a straight line. When you have a line of best fit, roughly the same number of points are above and below. A weak correlation would look like that. Again, there's a correlation there, but clearly the blue dotted correlation is much stronger. And this would be an example of a strong negative correlation. And a perfect positive correlation is 1.0. If it's perfect, that means it's literally a straight line. This one here would probably be about 0.9. This one would probably be about 0.4. This would be a very strong negative. It would be about negative 0.9. If all the points were exactly on the line, it would be negative 1.0. Okay? Now, it says here, is there a relationship? Yes, Anthony said that. It's a negative correlation. Not super strong, probably in the like negative 0.7 area. Okay? All right, any questions about this? All right, so what your job is to start your homework, get going on it, review that quiz over the weekend, because on Monday you get day 2, on Tuesday you get day 3. Monday's linear, I think Monday we're doing linear regression, and that's like the really last new thing of the year. Nini, you awake here or what? You sure? Because you look like you're about to doze. What's his name? No, I don't think there is a him because you're not extra happy right now. But if you get that extra happy thing going on when the girls can't control their smile, there's always a him. Maybe it's what?
Or maybe it's the destruction of the world.
The destruction of the world. Why is the world being destroyed? I thought